Welcome to MSN Digit Maths. I am N. Manjula, Assistant Professor, Department of Mathematics, Madurai Sivagasi Nadars Pioneer Meenakshi Women's College, Puvandi. Here is a learning resource for Calculus Unit 1, Module 1. In this video, we are going to see about successive differentiation, simple problems, trigonometrical transformations, problems using trigonometrical transformations. We start with a simple example. Suppose we have given y equal to 4x power 5. Differentiating with respect to x, we get dy by dx is equal to 20x power 4. Here we are using the formula differentiation of x power n equal to n into x power n minus 1. Again differentiating with respect to x, we get d square y by dx square equal to 80x cube. And also again differentiating, we get third derivative and so on. If y equal to f of x, the successive derivatives are denoted by f dash of x, f double dash of x, etc. f power n of x, or y dash, y double dash, etc. y power n, or y1, y2, etc. yn. Now we see about standard results. Result 1. If y equal to ax plus b power m, then we have to prove yn equal to m into m minus 1 etc. m minus n plus 1 into a power n into ax plus b power m minus n. Given y equal to ax plus b power m. So taking the first derivative, we get y1, that is equal to m into ax plus b power m minus 1 into a. Here also we are using the formula differentiation of x power n equal to n into x power n minus 1. Now take the second derivative. We get y2 equal to m into m minus 1 into ax plus b power m minus 2 into a square. Then third derivative will become y3 equal to m into m minus 1 into m minus 2 into ax plus b power m minus 3 into a cube. So proceeding like this, we write yn as m into m minus 1 etc. m minus n plus 1 into a power n into ax plus b power m minus n. In particular, d power n of ax plus b power minus 1. That is, in the previous result, we are using m equal to minus 1. So the answer will be minus 1 power n factorial a power n into ax plus b power minus n minus 1. Now we take the yn as m into m minus 1 etc. m minus n plus 1 into a power n into ax plus b power m minus n. Here we put m equal to minus 1. Then we arrive yn equal to minus 1, minus 2, minus 3, etc. minus n, a power n into ax plus b power minus 1 minus n. Here minus 1 is repeated as n times. So we can take minus 1 from these n terms. We write as minus 1 power n into 1, 2, 3, etc. n into a power n into ax plus b power minus n minus 1. So the answer will be minus 1 power n factorial a power n into ax plus b power minus n minus 1. Result 2. If y equal to log ax plus b, then yn will be minus 1 power n minus 1 factorial a power n into ax plus b power minus n. Usually differentiation of log x is 1 by x. We know that. Here y equal to log ax plus b. So if we take first derivative, y1 will be 1 by ax plus b into a. That we can write as a into ax plus b power minus 1. Now taking the second derivative, we get y2 equal to minus 1 into a into ax plus b power minus 2 into a. This can be written as minus 1 power 2 minus 1 a square into 2 minus 1 factorial ax plus b power minus 2. Now we proceed to third derivative. Y3 equal to minus 1 minus 2 into a square into ax plus b power minus 3 into a. This can be written as minus 1 power 3 minus 1 3 minus 1 factorial a cube ax plus b power minus 3. Proceeding like this, we get yn equal to minus 1 power n minus 1 factorial into a power n into ax plus b power minus n. Now result 3. If y equal to sin ax plus b, then yn will be a power n sin n pi by 2 plus ax plus b. Given y equal to sin ax plus b, taking the first derivative, y1 will be cos ax plus b into a. Now we have to write this answer in terms of sin. Then only we get yn as a power n into sin of n pi by 2 plus ax plus b. So a into cos ax plus b can be written as a into sin pi by 2 plus ax plus b, since we know that sin of 190 plus theta equal to cos theta. Now taking the second derivative, y2 equal to a into cos pi by 2 plus ax plus b into a. That is a square into cos pi by 2 plus ax plus b. This can be written as in terms of sin as a square equal to sin 2 pi by 2 plus ax plus b, since cos 90 plus theta equal to sin 180 plus theta equal to minus sin theta. So proceeding like this, we get yn equal to a power n sin n pi by 2 plus ax plus b. Now result 4. If y equal to cos ax plus b, then yn equal to a power n cos n pi by 2 plus ax plus b. Taking the first derivative, y1 equal to minus sin ax plus b into a. Here minus sin ax plus b can be written as cos pi by 2 plus ax plus b. Therefore y1 equal to a into cos pi by 2 plus ax plus b. Taking the second derivative, y2 equal to minus a cos ax plus b into a. That is minus a square cos ax plus b. This can be written as a square cos 2 pi by 2 plus ax plus b, since cos of 180 plus theta equal to minus cos theta. So proceeding like this, we get yn equal to a power n cos n pi by 2 plus ax plus b. Corollary. If a equal to 1 and b equal to 0 in results 3 and 4, we get d power n of sin x equal to sin n pi by 2 plus x, d power n of cos x equal to cos n pi by 2 plus x. We know the result d power n of sin ax plus b is a power n sin n pi by 2 plus ax plus b. Here we have to put a equal to 1 and b equal to 0. Then we arrive d power n of sin x equal to sin n pi by 2 plus x. Similarly, d power n of cos x is cos n pi by 2 plus x. Result 5. If y equal to e power ax into sin bx plus c, then we have to find yn. Given y equal to e power ax sin bx plus c, taking the first derivative, y1 will be e power ax into cos bx plus c into b plus a e power ax into sin bx plus c. This can be written as b into e power ax cos bx plus c plus a into e power ax sin bx plus c. Here we have to make use of the substitution a equal to r cos phi and b equal to r sin phi. then y1 will be e power ax into r cos phi cos bx plus c plus r cos phi sin bx plus c. Now we take r outside, we get r into e power ax into sin phi cos bx plus c plus cos phi sin bx plus c. This is in the form sin a cos b plus cos a sin b. So we can make use of the formula sin a plus b. So we arrive y1 equal to r into e power ax sin bx plus c plus phi. Now we proceed to second derivative. y2 will be minus b e power ax sin bx plus c into b plus b e power ax cos bx plus c plus a e power ax cos bx plus c into b plus a into a e power x sin bx plus c. That is minus b square e power ax sin bx plus c plus 2ab e power ax cos bx plus c plus a square e power x sin bx plus c. Here e power x is common in all the terms, so we can take e power x outside. So taking e power x, we get a square minus b square into sin bx plus c plus 2ab cos bx plus c. Here we have to put a equal to r cos phi, b equal to r sin phi. Then we get e power ax into r square cos square phi minus r square sin square phi sin bx plus c plus 2r square sin phi cos bx plus c. So we get e power ax into r square cos 2 phi sin bx plus c plus r square sin 2 phi cos bx plus c. This is in the form cos a sin b plus sin a cos b. So if we take r square outside, we get r square e power x into sin bx plus c plus 2 phi. So proceeding like this, we write yn as r power n e power ax sin bx plus c plus n phi, where r is a square plus b square power 1 by 2. Here we arrive this value as squaring and adding a and b, that is a is r cos phi, b is r sin phi. If we square and add, we arrive a square plus b square as r square. Therefore r equal to a square plus b square power 1 by 2. Similarly, we can find phi, that is we divide b by a. So b by a equal to r sin phi by r cos phi, which is equal to tan phi. So phi equal to tan inverse of b by a. Result 6. If y equal to e power ax cos bx plus c, then we have to find yn. This is same as result 5. Given y equal to e power x cos bx plus c, so taking the first derivative, we get y1 as a e power x cos bx plus c minus b e power x sin bx plus c. Here also we have to make use of the substitution a equal to r cos phi, b equal to r sin phi. Then we get y1 as e power x into r cos phi cos bx plus c minus r sin phi sin bx plus c. We take r outside, we get r e power x into cos bx plus c plus phi. Now we take the second derivative. y2 equal to a e power x into minus sin bx plus c into b plus a e power x cos bx plus c into a minus b e power x cos bx plus c into b minus b a into e power x sin bx plus c. E power x is common in all the terms, so we take e power x outside. Then we get a square minus b square cos bx plus c minus 2ab sin bx plus c. Here we make use of the substitution a equal to r cos phi, b equal to r sin phi. Then we get e power ax into r square cos 2 phi cos bx plus c minus r square sin 2 phi sin bx plus c. This is in the form cos a cos b minus sin a sin b. So we can write as r square e power x cos bx plus c plus 2 phi. So proceeding like this, we get yn as r power n e power x cos bx plus c plus n phi, where r is a square plus b square power 1 by 2 and phi is tan inverse of b by a. Now we see some of the examples using these results. Example 1, find yn where y equal to 3 by x plus 1 into 2x minus 1. Given 3 by x plus 1 into 2x minus 1. So we have to separate these terms using partial fractions. So we write this equation as a by x plus 1 plus b by 2x minus 1. So on simplification, we get the answer a and b as minus 1 and 2. So 3 by x plus 1 into 2x minus 1 can be written as minus 1 by x plus 1 into minus 1 by x plus 1 plus 2 by 2x minus 1. So y is equal to minus 1 by x plus 1 plus 2 by 2x minus 1. This can be written as minus of x plus 1 power minus 1 plus 2 into 2x minus 1 power minus 1. Now we take the nth derivative in this step. So d power n of ax plus b power minus 1. This can be written as minus 1 power n factorial a power n ax plus b power minus n minus 1. In the same way, we write the nth derivative of x plus 1 power minus 1. So that will be minus 1 power n factorial into 1 power n into x plus 1 power minus n minus 1. Similarly, nth derivative of 2x minus 1 minus 1. 2x minus 1 power minus 1. This can be written as minus 1 power n factorial 2 power n 2x minus 1 power minus n minus 1. So yn will be minus 1 power n factorial divided by x plus 1 power n plus 1 plus 2 into minus 1 power n factorial 2 power n by 2x minus 1 power n plus 1. Here in these two terms, minus 1 power n into n factorial is common. So we take outside, we arrive the answer. Next example 2, find yn where y equal to x square by x minus 1 whole square into x plus 2. Here also we have to make use of partial fraction. So the given equation can be written as a by x minus 1 plus b by x minus 1 whole square plus c by x plus 2. On simplifying, we get ABC as a equal to 5 by 9, b equal to 1 by 3 and c equal to 4 by 9. So y can be written as 5 by 9 into 1 by x minus 1 plus 1 by 3 into 1 by x minus 1 whole square plus 4 by 9 into 1 by x plus 2. Now we take the nth derivative in this step. So d power n of x minus 1 power minus 1 and d power n of x minus 1 power minus 2 and d power n of x plus 2 power minus 1 can be found out. So therefore yn will be 5 by 9 into minus 1 power n factorial by x minus 1 power n plus 1 plus 1 by 3 minus 1 power n plus 1 factorial by x minus 1 power n plus 2 plus 4 by 9 minus 1 power n factorial by x plus 2 power n plus 1. Example 3. Find yn where y equal to 1 by x square plus a square. Here x square plus a square can be written as x plus ia into x minus ia. Now we write this equation into partial fraction as a by x plus ia plus b by x minus ia. On simplifying, we arrive a as minus 1 by 2 ia, b as 1 by 2 ia. On substituting these values, we get y equal to 1 by 2 ia into minus 1 by x plus ia plus 1 by x minus ia. Now at this step we take the nth derivative, then we get yn equal to 1 by 2 ia into minus of minus 1 power n factorial x plus ia power minus n minus 1 plus minus 1 power n factorial x minus ia power minus n minus 1. Here minus 1 power n factorial is common, so we take outside, then we get minus 1 power n factorial by 2ia into 1 by x minus ia power n plus 1 minus 1 by x minus ia power n plus 1. And then trigonometrical transformations. Let us see the problem. Find the nth differential coefficient of cos x, cos 2x and into cos 3x. We know the formula cos a cos b equal to 1 by 2 cos a plus b plus cos a minus b. Also cos square a can be written as 1 plus cos 2a by 2. So we make use of these two formulas in this problem. Now given problem is cos x, cos 2x, cos 3x. This can be taken as cos 2x into cos x into cos 3x. So we make use of the equation 1 in cos x into cos 3x. So the given equation can be written as cos 2x into 1 by 2 into cos 4x plus cos 2x. Multiplying cos 2x, we arrive 1 by 2 into cos 2x cos 4x plus 1 by 2 into cos square 2x. Then we get 1 by 2 into 1 by 2 cos 6x plus cos 2x plus 1 by 2 into 1 plus cos 4x by 2. On simplifying, we get 1 by 4 into 1 plus cos 2x plus cos 4x plus cos 6x. So d power n of cos x, cos 2x, cos 3x equal to 1 by 4 into d power n of 1 plus d power n of cos 2x plus d power n of cos 4x plus d power n of cos 6x. We know that the nth derivative of a constant is 0. So 1 by 4 into 0 plus 2 power n cos n pi by 2 plus 2x plus 4 power n cos n pi by 2 plus 4x plus 6 power n cos n pi by 2 plus 6x. Since we know that d power n of cos x is cos n pi by 2 plus 6. In the same way, we can find the nth differential coefficient of cos power 5 theta into sin power 7 theta. Here we are using x is equal to cos theta plus I sin theta. Then 1 by x will be cos theta minus I sin theta. Adding these two equations we get 2 cos theta. Subtracting we get 2 I sin theta. So we are using de Moivre's theorem. So for cos power 5 theta we have to take 2 power 5 cos power 5 theta. This can be written as x plus 1 by x power 5. 2 power 7 I power 7 sin power 7 theta equal to x minus 1 by x power 7. So multiplying these two equations we arrive 2 power 12 minus I cos power 5 theta sin power 7 theta. In the right hand side we have to multiply the respective equations. So we have to take the common terms, that is in power 5 we are having common term. So x plus 1 by x power 5 x minus 1 by x power 5 into x minus 1 by x power 2. So we get x square minus 1 by x square power 5 into x minus 1 by x power 2. Using binomial expansion and multiplying all the terms we arrive x power 12 minus 1 by x power 12 minus 2 into x power 10 minus 1 by x power 10 minus 4 into x power 8 minus 1 by x power 8 plus 10 into x power 6 minus 1 by x power 6 plus 5 into x power 4 minus 1 by x power 4 minus 20 into x square minus 1 by x square. So we write this equation as 2i sin 12 theta minus 2 into 2i sin 10 theta minus 4 into 2i sin 8 theta plus 10 into 2i sin 6 theta plus 5 into 2i sin 4 theta minus 20 into 2i sin 2 theta. We take 2i as a common term and cancelling 2i on both sides, we get minus 2 power n cos power 5 theta sin power 7 theta equal to sin power 12 theta minus 2 sin 10 theta minus 4 sin 8 theta plus 10 sin 6 theta plus 5 sin 4 theta minus 20 sin 2 theta. Taking nth derivative, we arrive minus 1 by 2 power 11 12 power n cos sin n pi by 2 plus 12 theta minus 2 into 10 power n sin n pi by 2 plus 10 theta minus 4 into 8 power n sin n pi by 2 plus 8 theta plus 10 into 6 power n sin n pi by 2 plus 6 theta plus 5 into 4 power n sin n pi by 2 plus 4 theta minus 20 into 2 power n sin n pi by 2 plus 2 theta. In the same way, we can solve these two problems. Here we have to find nth derivative of sin cube x. So we write sin cube x using the formula sin 3x. Sin 3x is equal to 3 sin x minus 4 sin cube x. From this equation, we find sin cube x as 1 by 4 3 sin x minus sin 3x. On taking nth derivative, we arrive 1 by 4 into 3 sin n pi by 2 plus x minus 3 power n sin n pi by 2 plus 3x. Then example 4, we have to find nth differential coefficient of e power x into sin x. For this problem, we have to use result 5, that is d power n e power x sin bx plus c. The answer is r power n e power x sin bx plus c plus n5. Here d power n e power x sin x equal to r power n e power x sin x plus n5, where r is 1 plus 1 power 1 by 2 which is equal to root 2 and phi is tan inverse of 1 by 1 which is equal to pi by 4. So d power n of e power x sin x equal to 2 power n pi by 2 e power x sin x plus n pi by 4. Thank you.